In this clip, we'll investigate the properties of a cost function. So you can see the cost function q to the third minus 16q squared plus 100q plus 200. It's only defined for positive q, positive quantities. That usually makes sense. The leading term here is a q to the power of 3. That means if you look at the cubic function, it looks something like this. So quite likely we are to encounter elements of this function or subdomains of this function where the function is either concave and perhaps another subset for the input q where the function is convex. Okay, and this is now the question. Find out where the cost function is increasing, where it is concave, and where it is convex. So here's our first derivative, 3q squared minus 32q plus 100. When is that 0? So we can try, you can of course try and solve that, but if you remember your solution formula for the quadratic equation, you possibly realize that there's a term of which you take a square root, and that term here would be 32 squared minus 1200. That is negative, and taking the square root of a negative number, you will realize there is no real solution. So there's no real number q for which the c prime is equal to 0. So what does that mean? That means c prime, which is the marginal cost function, how the cost will change if you produce an additional unit, it will always be positive. So actually it turns out, just so far, it could be either always positive or negative. But let's plug in the smallest possible value for q, 0. So what's the first derivative of c at the value of 0? It's 100. It's positive. And c prime q will be positive for all q larger than 0, or even larger or equal to 0. So the cost function is strictly increasing. It's always, c prime is always positive. So what about the second derivative? So here's our first derivative. We take the derivative of that. That gives us the second derivative, 6q minus 32. Now, it turns out that is 0. That is smaller than 0 for 32 over 6. How can we see that? 6q minus 32 is a linear equation, right? So if you plot that, the intercept is negative 32 and the slope is 6. So some fairly steep slope. So it starts negative, and then after some value it will be positive. The root of that second derivative is 32 over 6. So that's where the second derivative is equal to 0. So it means we have this red area here. So values of q smaller than 32 over 6, where the second derivative is smaller than 0. And that means the function, the original cost function, is concave. And then we have this area of the domain, q for q is larger than 32 over 6, where the second derivative is larger than 0, and therefore the cost function is convex. So we've basically answered our question. The cost function is increasing everywhere in the domain, and we have two areas, one where the function is concave and one where it is convex. That's the green area. At the point 32 over 6, the function is both convex and concave.